Throughout 3 years, the most powerful telescope that humanity has ever built has been quietly pointing again and again at one faint icy dot lying nearly 6 billion kilometers away from us. And almost every time it sends data back, it shows us something that, according to all current understanding, should not exist out there. This is a strange world in that it is the only object in the entire history of astronomy to be discovered, named, celebrated, and then voted by humans themselves to be stripped of the title that once made its name, and for many years afterward everyone thought the story about it ended there. Then James Webb aimed its giant golden eye toward Pluto, and the light reflected back through that mirror was something no one was prepared for. This is the story of what that telescope found out in the cold darkness at the edge of the solar system, and why it should unsettle you more than almost any other discovery of this century. Because every time Webb looks again, Pluto becomes stranger than before. This channel specializes in breaking down real universe discoveries without exaggeration, without clickbait, so if that is what you want, then subscribe right now. But to understand why this data is so frightening, let us go back to where the story truly began. The story began in the year 1930 at an observatory in Flagstaff, Arizona, where a 24-year-old guy named Clyde Tombaugh was assigned one of the most tedious jobs you can imagine. He photographed the same patch of night sky on different nights, then sat for hours flipping back and forth between the glass plates, straining his eyes to search for one single point of light that had moved position among thousands of motionless stars behind it. They hired him to hunt for a hypothetical planet that astronomers believed was lurking at the edge of the solar system, something massive enough to disturb the orbits of Neptune and Uranus, which they called Planet X. Tombaugh went looking for a planet, and after many months of tireless effort, he found one. That quietly drifting point of light became Pluto, and for nearly a century afterward it held the position of the 9th planet, a name that any child knew by heart. Then in the year 2006, humans voted to strip that title away. And the important thing is that this was not a conspiracy at all, but the result of a continuous scientific process tightening its own definition. In the 19th century, there was a time when the solar system was thought to have up to around 20 planets, because every time someone discovered a large moon or an asteroid, they hastily bestowed that title on it, and that chaos had to be corrected. At the time Pluto was found, an object only needed to meet 2 criteria: orbit the Sun and stand out alone in its region. Pluto then matched both. But by the year 2006, astronomers added a third, harsher criterion, that a true planet must have enough gravitational force to clear its own orbit, to absolutely dominate its region of space. And that is exactly where Pluto stumbled, because it was not alone at all, but only one among countless objects crowding the cold edge of the solar system. And here is the most ironic detail. What directly triggered the demotion was Eris, a celestial body discovered in the year 2005 by astronomer Mike Brown, and initially thought to be larger than Pluto. Yet when measurements were refined later, it turned out Eris was actually a little smaller than Pluto. In other words, the executioner turned out to be smaller than the very victim it put to death. For a long time, all of that made people believe this was the end for Pluto, a small distant world, easily pushed aside and forgotten. But that seemingly solid assumption did not survive when humans first touched real data. To see how extraordinary that is, we need to pause for a moment on how little we once knew about Pluto before any spacecraft reached it. For most of the 20th century, even the largest telescopes on Earth could only see Pluto as a blurry, faint dot, unable to resolve it into a clear surface. Astronomers could calculate its orbit fairly accurately, because that only required tracking its position over time, but its true size, what its surface was made of, and whether it had an atmosphere or not, all remained open questions for decades. Even worse, some early estimates actually inflated Pluto's size a lot, because people thought it had to be large enough to explain the deviations in the orbits of Neptune and Uranus, deviations that later turned out to be just measurement errors and had nothing to do with Pluto at all. One reason we were so wrong about the size is because Pluto reflects light extremely strongly, among the shiniest objects we know, so from that vast distance it looked much larger than it really was. In other words, almost everything the public believed about Pluto for generations was guesswork piled on guesswork. And even its orbit was already a peculiar thing. While nearly everything orbiting the Sun lies neatly on one flat plane like a disk, Pluto's orbit is an ellipse tilted a full 17 degrees from that plane, an orbit so distorted that there are periods when it slips inside even Neptune's orbit. Pluto was strange right from the way it moved, and all of that only made what happened next even more extraordinary. In July of the year 2015, after a journey lasting 9.5 years across billions of kilometers of empty space, NASA's New Horizons spacecraft sped past Pluto at more than 50,000 kilometers per hour. It had only one single chance, no orbit around, no flyby again, only a narrow window of just a few minutes to gather everything it could before speeding onward into eternal darkness, and what it sent back completely overturned everything science thought it already knew. On the surface appeared a giant heart, a pale, bright, icy region nearly 1,600 kilometers wide, slightly off-center, standing out stunningly amid the dark surrounding terrain. Mountain ranges built from rock-hard water ice rose nearly 11,000 feet into the thin sky, frozen so solid they no longer behaved like ice, but like real granite. The sprawling nitrogen plains were slowly rolling along in giant convection cells, as if the surface itself was renewing, a sign that something warm seemed to be stirring beneath the crust everyone thought had been dead frozen for ages. And covering it all were dozens of layered blue haze layers stacked on one another, rising up to 300 kilometers above the surface, faintly glowing even when lit from behind by the sun. Pluto was nothing like a forgotten leftover frozen rock chunk at the edge of the solar system. It looked like a world still in the process of becoming something. But New Horizons only got that one single view and then sped away forever, and anything it missed in that flyby moment would remain a mystery for many years. What science really needed was not a prettier picture, but a way to read straight into Pluto's chemical makeup from billions of kilometers away, without launching any more spacecraft. And that is exactly what the James Webb Space Telescope finally accomplished, because Webb operates on a completely different principle from a spacecraft like New Horizons. Webb does not fly anywhere and does not take portraits, but instead it reads the light itself, splitting the light into individual wavelengths to reveal the precise chemical fingerprint of what it is looking at, aiming at a faint reflected point of light billions of kilometers away. From its position about 1.5 million kilometers from Earth, Webb only needs to stand still and let each photon do the work, and from that it can tell what molecules are present, how the atmospheric layers are warm or cold, and how that atmosphere is changing over time. But the technical challenge here is worth pausing to ponder, because from Webb's viewpoint, Pluto and its giant moon Charon lie so close together that separating the thermal signal of each body had previously been almost impossible. For generations of earlier telescopes, the warmth of the two worlds blurred together into one, and no one knew which heat belonged to Pluto and which to Charon right beside it. It was the giant mirror 6.5 meters in diameter together with the highly sensitive infrared instrument named MIRI, which reads wavelengths from about 5 to 27 micrometers, that for the first time in history cleanly separated Pluto's thermal signal from Charon's. Starting in the year 2022, as soon as the instruments were powerful enough to distinguish Pluto's faint signal from its large companion, Webb turned its gaze toward it and recorded separate thermal light curves. By May of the year 2023, it gathered an additional detailed mid-infrared spectrum in a range no one had surveyed before, and then in June of the year 2025, the first results were officially released. And what came back after all that time was not simply a prettier image, but something close to a comprehensive diagnosis, revealing a series of strange behaviors that researchers are still struggling to explain. Because this was not one single look and done, but for 3 full years, Webb patiently kept returning to the same icy dot, adding a new data point every few months, and nearly every look back made the picture of Pluto stranger than before. If you want universe stories told clearly, instead of buried in dry terminology, leave a like right now, because that really helps this kind of content reach more people. The first major discovery appeared as soon as Webb separated Pluto's own thermal signal from Charon's, because for 3 full years, the temperature numbers it sent back kept being consistently lower than every model scientists had ever built. And to understand how shocking that is, it is necessary to know that before, based on an atmosphere made mostly of nitrogen with some methane and carbon monoxide, models had predicted Pluto's upper atmosphere should be around 100 Kelvin, or about minus 173 degrees Celsius, terribly cold but still within expectations for a world so far from the sun. Yet when measured directly, the results were only around 65 to 70 Kelvin, a difference of more than 30 degrees from the prediction, a huge gap in the eyes of planetary scientists, and it meant something was cooling the atmosphere far more effectively than any calculations. The clue lay in the haze layer itself. Back in the year 2017, a planetary scientist named Shi Zhang at the University of California in Santa Cruz had put forward an idea that sounded almost backward at the time. On Titan, Saturn's moon, the haze layer traps heat and warms the world below, but Zhang argued that Pluto's haze layer might be doing the complete opposite, absorbing daytime sunlight and then radiating all that energy back out into space as mid-infrared, shedding heat faster than the thin atmosphere could retain it. In other words, the haze did not behave like a blanket, but like a radiator, actively draining warmth from a world that already had almost nothing left to lose. At the time, this idea made many of his colleagues skeptical, and there was no instrument sensitive enough to verify it. Then Webb appeared, and an international research team led by astronomer Tanguy Bertrand used its very own infrared instrument to measure directly, and in results published in the journal Nature Astronomy in June of the year 2025, they confirmed almost exactly what Zhang had predicted 8 years earlier. Pluto's haze layer really was radiating warmth outward, and this was the first time humans had witnessed solid particles suspended in the air rather than gases, controlling the climate of an entire world, something that completely overturned a long-standing assumption of planetary science. Researchers now describe this as an entirely new kind of climate, a world not simply cold because it is far from the sun, but actively cooling itself. And what is astonishing is that this mechanism may be quietly shaping the climates of other hazy worlds like Titan or Triton, even on distant exoplanets, and who knows, might even echo back to the hazy skies of a young Earth billions of years ago, when our own atmosphere was perhaps also filled with similar hydrocarbon hazes. But if the self-cooling haze was strange enough, the next discovery is what scientists really cannot explain, and it relates directly to Pluto's surface itself. In June of the year 2026, a research team led by astronomer Bruno Bazard at the Paris Observatory announced that when analyzing the spectral data Webb had obtained, they found a strange light absorption feature at the wavelength of 5.113 micrometers on Pluto's surface, and what was puzzling was that the exact same absorption feature also appeared on the surface of Titan, Saturn's moon. This was not a faint signal easy to mistake, because it showed up independently in data from two separate instruments on Webb, meaning it was almost impossible to be a machine error, and when scientists compared the spectrum at the disk center with the spectrum at the disk edge, all signs pointed to this signal coming from the solid surface itself rather than the atmosphere. The problem was when they matched that absorption feature against dozens of known compounds in laboratory spectral libraries, benzene, propadiene, ketene, acetylene, and many others, none matched perfectly. A few came teasingly close, but all were off just enough to rule out any certain identification. To understand why this is so astonishing, it is necessary to know that Pluto's surface is already covered with a type of organic material that scientists thought they understood fairly well. Even the feeble sunlight, thousands of times fainter than on Earth, when it reaches Pluto's upper atmosphere, is still strong enough to break apart methane molecules, and those fragments do not simply vanish but recombine into heavier compounds: ethane, acetylene, ethylene. An entire garden of hydrocarbons growing larger as they fall into the colder lower layers, eventually clumping into red-brown organic particles called tholins, slowly settling to blanket the surface for nearly 4 billion years like an endless chemical snowfall. What touches people about this detail is that tholins belong to the same family of organic molecules that many scientists believe once rained down into the primordial chemical soup on Earth, the soup from which life later emerged. Yet even tholins, that familiar material, could not explain the mysterious absorption feature, and when compared with every type of recorded hydrocarbon ice, still nothing matched. In other words, Webb had found traces of something completely outside the entire chemical catalog humans had ever compiled, a material with no name, appearing simultaneously on two worlds separated by vast gulfs of temperature, pressure, and geology, and no one on Earth knows for sure what it really is. And if an unnamed material on the surface was not puzzling enough, then there is another mystery about Pluto that challenges even more basic laws of physics, to the point that to explain it, the scientific community had to bring in a completely different eye, that is the X-ray observatory named Chandra. During the time around New Horizons flyby, Chandra had pointed toward Pluto multiple times, and what it recorded left everyone stunned, because Pluto was emitting X-rays. This was something that should not happen, because X-rays from celestial bodies are usually generated through interaction with magnetic fields, and Pluto is a cold, lonely world with no known magnetic field at all. Not only that, the intensity of the X-rays that Chandra measured was far stronger than any mechanism scientists could imagine to explain it. The most plausible hypothesis is that the X-rays were generated when the solar wind, the stream of charged particles blowing out from the sun, collided and exchanged charges with gas molecules escaping from Pluto's atmosphere. But here, a direct contradiction arose between the two instruments, because New Horizons itself, when flying past and measuring on site, discovered that the solar wind in Pluto's vicinity was much weaker than expected, weak to the point of being only about 1/40th of the level needed to produce the amount of X-rays that Chandra observed. In other words, one spacecraft measuring on site said the solar wind there was too weak, while a telescope from afar insisted that the X-ray signal was too strong, and the two results simply did not match each other. Additional observations should have helped settle it, but when the European Space Agency's X-ray telescope XMM Newton tried to measure again, it still could not confirm the initial finding, partly because of unfavorable observing geometry, partly because the amount of X-rays coming from Pluto was already too faint to capture with certainty. It must be said outright that this is not a mystery that has been solved, but a question that still hangs in the air, not closed at all, a question mark that science to this day honestly admits has no complete answer. And perhaps it is exactly that honesty that is worth treasuring, because instead of hastily covering it up with an explanation to be done with it, scientists chose to leave the question open and keep measuring. As for you, what do you think is making a frozen world without a magnetic field emit X-rays so strongly? Leave a comment below to let me know your thoughts, because mysteries left open like this are always where the most interesting conversations begin. But perhaps the strangest thing about Pluto lies not in itself, but in its relationship with its giant companion, the moon Charon. Charon is nearly half the size of Pluto, a size ratio so small that it is almost unseen in any other planet-moon pair, and it orbits Pluto at a distance of only about 19,600 kilometers. Precisely because Charon is both large and close like that, it does not really orbit Pluto the way our moon orbits Earth, but the two together orbit a common point floating in the empty space between them, to the point that some people half joked that they were spinning around a tiny black hole, though in reality it is just gravity behaving strangely. And it is very hard to imagine how an object as large as Charon could have accidentally been grabbed by Pluto and held tightly in orbit. For many years, the popular hypothesis was that Charon formed like Earth and the Moon, meaning a violent collision that sent molten material flying out and then coalescing. But in January of the year 2025, a study in the journal Nature Geoscience led by scientist Adine Denton showed that the old hypothesis collapsed as soon as people factored in an element that had been forgotten for decades, that is the structural strength of cold, icy worlds. When that was taken into account, the simulations produced a completely new scenario, where Pluto and Charon collided and stuck together for dozens of hours, spinning like a cosmic snowman, before separating but remaining forever bound in each other's orbit, a mechanism called kiss and capture. The important thing is that Charon was not crushed into fragments, but remained almost intact, meaning it could be as ancient as Pluto itself, an independent world that was captured rather than a child born from the rubble. And what makes this discovery even more convincing is that it is not alone, because out there is also Triton, Neptune's largest moon, and in fact a Kuiper Belt object even larger than Pluto. It is almost certain that Triton was once half of a binary system like Pluto and Charon, until it drifted too close to Neptune and the giant planet's gravity tore the pair apart, slinging the companion away while Triton lost enough momentum to be captured. In other words, the mechanism of capturing a world from a binary system is not at all a one-off event, but seems to have happened at least twice at the cold edge of the solar system, and Pluto and Charon are still there, forever locked together in a slow waltz that began from a primordial collision. And it is precisely that locked waltz that leads straight to one of the most persistent mysteries about Pluto, hidden right in the famous heart region of it. The western lobe of the heart, a giant nitrogen ice plain named Sputnik Planitia, lies in a position it should not have. By the usual rules, a deep, heavy basin like that should be gradually pushed by the planet's rotation toward one of the two poles, yet Sputnik Planitia lies almost right on the equator, and even more notably, it lies almost exactly on the opposite side from Charon, a coincidence that scientists believe is not random at all. The evidence here is not a picture, but a pattern. That strange position implies that beneath this basin there must exist a positive mass concentration, something unusually heavy, anchoring the entire heart region right in the spot opposite Charon. And Sputnik Planitia is strange in that its surface is perfectly flat, almost without a single impact scar, a sign that it is continuously renewing itself, erasing every scar in the blink of cosmic time. Elsewhere on Pluto, two giant solitary mountains rise above the landscape, Wright Mons about 5 kilometers high and up to 150 kilometers wide, along with Picard Mons even higher, possibly up to nearly 20,000 feet. But these are a completely different kind of mountain from the rock-hard water ice ranges that New Horizons once saw, because both of these have a deep pit at the summit and rugged slopes that look exactly like cooled lava flows, and scientists believe they are cryovolcanoes, which once erupted not molten rock, but a slushy mixture of water, ammonia, and methane pushed up from deep beneath the crust. Together with cracks and ridges on the surface, aligned exactly the way a layer of liquid moving underneath would create, all of it points to an undeniable conclusion. There must be some heat source warm enough under the ice crust to push liquid material all the way to the surface. As for that heat source, there are currently two competing explanations. One side says it is a salty subsurface ocean lying about 100 miles deep, kept warm by slow radioactive decay in Pluto's rocky core, similar to the hidden oceans suspected beneath Europa, Enceladus, or even Triton, while the other argues that it is the rocky core of an ancient impactor that created that mass concentration without any ocean at all, and to this day, that debate has not been settled. But among all that Webb and other instruments have revealed, perhaps what unsettles people the most is the fate of Pluto's atmosphere itself, because it is dying right before our eyes. To track this, scientists use a technique called stellar occultation, observing how the light of a star dims as Pluto passes in front of it, and from that measure atmospheric pressure. The results show that from the year 1988 to the year 2015, Pluto's atmospheric pressure had tripled, then stayed at a plateau, and what is astonishing is that this happened precisely while Pluto was moving farther away from the Sun, something that should have made it cooler and caused the atmosphere to shrink. Yet the latest verdict, from an analysis published in the year 2026, shows that since around the year 2022, that pressure has begun to drop, the first sign that the contraction has started. And to understand what is happening, imagine Pluto as a planet that knows how to breathe. Its orbit lasts 248 years and is so distorted that there are periods when it is pushed so far from the sun it is frightening, and when that distance reaches a certain threshold, the temperature drops just enough for the nitrogen gas in the atmosphere to condense and snow down to the ground. The entire atmosphere, in the literal sense, freezes and falls from the sky like a silent ice storm, accumulating as frost on the cold side of the world and lying there, sometimes for an entire century, until Pluto's next close approach to the sun when it sublimates back into gas. This is a planet that breathes on a 248-year cycle, and right now it is exhaling. What makes that image even more haunting is that the material of that snow is nitrogen, the gas that makes up most of the air you are breathing right now, except on Pluto it falls as snowflakes, while methane freezes into rivers of ice. The surface pressure right now is only about 1/100,000th of Earth's, unimaginably thin, but it is not still at all but a living, pulsing atmosphere that is vanishing right before an instrument just sensitive enough to witness it. And that creates two countdown clocks running at the same time. The first is that models predict that in the coming decades, this atmosphere could freeze almost completely. The second is even more grim, because as Pluto recedes farther from the star-crowded part of the Milky Way behind it, the chances of it passing in front of a star bright enough grow fewer, meaning the very tool that allows us to observe that atmosphere is also slowly closing its door. We may be witnessing a world holding its breath right at the moment the window to see it is gradually slamming shut. And this is exactly what makes all these discoveries even more haunting. We have almost no way to go back and verify more. There is currently no mission funded to send a spacecraft back to Pluto, no orbiter, no lander, nothing at all. And the reason is brutally simple. A trip to the edge of the solar system is horrendously expensive and agonizingly slow, usually requiring a full decade or more just to get there, and after all those years of waiting, it only buys a short window to gather data. Space agencies always have to weigh such a mission against a host of other priorities that are closer, cheaper, and yield results faster, and in that balance, distant icy worlds like Pluto almost always lose out, not because scientists have lost interest, but because the cost and the time frame are too harsh. So right now, Webb remains the best tool we have to read Pluto in detail, and every few months, each time Pluto comes back into the sky region that Webb can look at without damaging its sensitive instruments, the telescope quietly turns toward it and adds another data point, taking that 3-year story into its 4th year. And here is the detail that lingers longest in people's minds after hearing this entire story. Pluto is not special only because of itself, but because it lies inside the Kuiper Belt, a giant ring of icy debris stretching beyond Neptune's orbit, home to hundreds of thousands of objects wider than 60 miles along with an estimated hundreds of billions of comets. Farther out, beyond the edge of the Kuiper Belt, there is believed to be the Oort cloud containing another roughly 1 trillion icy bodies stretching out to nearly 1/4 of the way to the nearest star. The Kuiper Belt alone is hundreds of times wider than the familiar asteroid belt between Mars and Jupiter, yet unlike the asteroid belt which has been mapped quite meticulously, that vast region of space remains almost entirely unexplored territory. You still remember Eris, the one that dethroned Pluto? Well, it is only one of a few rare objects of near Pluto size out there, alongside names like Make, while the rest are countless smaller worlds scattered about. And to this day, only New Horizons has ever gone deep enough into that region to take close-up pictures, and it only managed to fly past exactly 2 objects, Pluto and a smaller, farther one named Arakoth, out of hundreds of thousands of similar worlds believed to be floating out there. In other words, at the edge of the solar system is a crowded graveyard to the point we cannot even count the bodies, and each one of those bodies could be quietly running its own slow version of organic chemistry. Each one could be hiding an ocean beneath its crust, while Webb has only squinted at a few of the brightest among them. The most vivid proof of that is Triton itself, Neptune's largest moon, because Triton carries within it almost the entire strange catalog of Pluto, from nitrogen ice surface, red-brown thalin streaks, a suspected subsurface ocean, cryovolcanic activity, to a seasonally variable hazy atmosphere, except it sits there as the moon of a giant planet. Triton proves a spine-chilling truth. What Pluto is doing is not at all a rare exception, but the portrait of an entire class of worlds we have never truly looked at. So where does all of this ultimately lead us? If one tiny icy dot, once looked down upon and dismissed, could hide within itself so many things that should not exist, then what are the hundreds of billions of remaining worlds out there concealing? Pluto has never been the final postscript at the last page of the textbook. It is a warning that out there are countless things quietly doing far more than we ever imagined, and we have only just begun to look. When New Horizons flew past Pluto, it is said that the images sent back haunted even the most veteran scientists of the mission, not because they were scary, but because they were so beautiful and surprising that they overturned everything they thought they knew. And Webb is still out there. The fourth year has just begun, patiently returning to that icy dot time after time, so the next data cycle could very well add another strange piece to the puzzle. If you want to be there when that happens, subscribe to the channel and turn on notifications, because the story of Pluto clearly still has a long way to go before it ends. Thank you for watching, and see you in the next video.